So this next video is going to be over Module 6 and Module 7. So these two modules are together. The assessment will be combined. Your assessment is going to be a total of 18 questions coming from both of these modules. So I am going to go over some of the stuff that is important for you to know from the notes, and then I'm going to be looking at the homework assignments for each of these lessons and working the problems that you will find on the assessment. So the first lesson of Module 6 is over synthetic division. It says that synthetic division provides an efficient process for dividing a polynomial in x by a binomial of the form x minus k. So that is important. Your denominator does need to be in the form of x minus k. So you'll begin by writing the coefficients of the polynomial in decreasing powers of the variable. Use 0 as the coefficient of any missing powers, and then the number k is written to the left in the same row. So basically what we're going to be doing is we're going to be given a polynomial. In this case we have 5x cubed minus 6x squared minus 28x minus 2. So all of our exponents need to be in decreasing order, and then we're dividing this by x plus 2. Now, since we need it to be in the form x minus k, then we would need to do x minus, and our k in this one would be -2. So we are going to be dividing by -2 for k. So this example does show you're basically going to just use your numbers 5, -6, -28, and -2, and we are dividing by -2. When you divide, your first step is to bring down your 5. When you bring this down, you can then multiply 5 times -2. That's where they get the -10. You can then perform the operation -6 minus 10, you get -16. You are now going to multiply that by -2, and we get positive 32. Positive 32 and -28, we get positive 4. Positive 4 times that -2, and we end up with -8. -8 and -2 gives us -10. This is our remainder. Our remainder we are going to put over what we started with, our denominator, which was x plus 2. And there is a remainder theorem, which is in the notes. The remainder theorem that says, since the remainder is -10, there exists a point on the graph -2, -10. Okay, here's another example. Again, x plus 1 needs to be in the form of x minus 1, so you're going to divide by -1 for k. You are going to put a 0, since we have x to the 4th plus x squared minus 3x plus 1. So we don't have anything for x cubed, so you will put a 0 there. And here's the answer, and then similarly, there's a point on the graph. So look at these examples. So this one, they actually tell us that k equals 5i, and we're dividing by 3x squared plus 75. So we have 3. For x, we don't have anything, so it's going to be 0. And then 75, remember our first number comes down, and we're going to multiply 3 times 5i. Let me bring our arrow down. And we get 15i. When we add these two together, we still have 15i. We can now multiply that times 5i. 15 times 5 is 75. I times I equals -1. So I squared equals -1. So we are left with -75, and whenever we add these two together, our remainder equals 0. All right, for 6.2, we are going to factor polynomial expressions. All right, the factor theorem, let me highlight. For any polynomial function f of x, x minus k is a factor of the polynomial if and only if f of k equals 0. Okay, so that's what this is up here, just an example of this theorem. The next theorem that we have is the number of zeros theorem. It says that the fundamental theorem of algebra says that every function defined by a polynomial of a degree 1 or more has a 0, which means that every such polynomial can be factored. And then if you look right below that, the theorem, a function defined by a polynomial of degree n has at most n distinct zeros. Distinct meaning different zeros. And then here is an example. We're going to use the factor theorem and synthetic division to determine whether the second polynomial is a factor of the first. So we do synthetic division for this. We have -2, 1, 0 because there is no x, and then we have -63. So we're going to bring our -2 down. And we're going to multiply this by -3. Remember, this has to be in the form x minus k, so this has to be negative. -2 times -3 gives us a +6. We add these two together and we get +7. 7 times -3, we get -21. Add it to the 0 and it's still -21. Now we're going to multiply -21 by -3 and we get +63. So 0 is our remainder. So if remainder is 0, a 0 of f of x is a root or a solution. So that means that -3 is going to be one of the zeros, and that x plus 3 is a factor of the polynomial. Here's another example using the imaginary number. For the rational zeros theorem, if p over q is a rational number written in lowest terms, and if p over q is a 0 of f, a polynomial function with integer coefficients, then p is a factor of the constant term and q is a factor of the leading coefficient. So if you look at this example, p is over here to the right, and then we have q over here. Q is above the leading coefficient. the conjugate zeros theorem. If f of x defines a polynomial function having only real coefficients, and if z equals a plus bi is a zero of f of x, then z equals a minus bi is also 0, where a and b are real numbers. Okay, so look at these notes. 6.3, construct polynomial expressions which have given properties. So 6.3, we are working backwards. They are going to give us the zeros of a polynomial, and then we're going to figure out what it is. So there is an example that you can look at, and it has a little bit of explanation. So look at this, and I'm going to do the homework questions for 6.1, 6.2, 6.3. All right, so this is the homework for 6.1. And I'm going to work through some of these questions. I'm going to do some of the ones that are similar to the questions that are on the test. So I'm going to look at starting off with number 2. So this is 6.1, number 2. And we are going to divide, and we've got 5x to the 4th minus 14x cubed plus 12x squared minus 9x plus 2 divided by x minus 2. All right, so don't get confused with this denominator. We know that we want this in the form of x minus k. And whenever it's x plus k, we make it negative by making our k negative. In this case, we already have it negative, so k is going to equal positive 2. So this is what we're going to be dividing by. I'm going to bring all of our numbers down. I have 5. We're starting with our highest coefficient, 5. Moving on to the next one, negative 14. Positive 12, negative 9, and positive 2. So my k equals 2. All right, remember our 5 is coming down. We're going to multiply 5 times 2, which gives us 10. 10 and negative 14 gives us negative 4. I can now multiply negative 4 times 2, which is going to be negative 8. Negative 8 and positive 12 is a positive 4. 4 times 2 is 8. 8 and negative 9, I get negative 1. Negative 1 times 2 is negative 2. And what do you know? We have a 0 as our remainder. So what we are left with is 5x cubed minus 4x squared plus 4x minus 1. Okay, so 5x cubed minus 4x squared plus 4x minus 1. Okay, so you will have a question like that on the test. And there will be a question like this, number 3. So we have x cubed minus 64 divided by x minus 4. So our k is already, our form in our denominator is already x minus k. So in this case, k equals 4. And we can bring our numbers down. I have 1x cubed, so I'm just going to have a positive 1. We have nothing for x squared, and we have nothing for x. And then we have negative 64 at the end. And our k equals 4. So I'm going to bring our 1 down, and I can multiply that by 4, which gives us 4. 4 and 0 is 4. 4 times 4 equals 16. And then 16 times 4 equals 64. So these cancel out, and we have a remainder of 0. So we are left with x squared plus 4x plus 16. Okay, great. I'm not going to look at number 4. I am going to look at number 5. It says to use the remainder theorem and synthetic division to find f of k for the given value of k. So in order to find this, okay, my f of x equals 2x cubed minus 12x squared minus 16x minus 3, and then k equals negative 4. So since k equals negative 4, if I'm working backwards, we have x minus negative 4, and so we have x plus 1 for our denominator. So I'm going to, x plus 4. I'm not sure where I got 1 from. Okay, so I am missing a negative right here. So I have negative 2, negative 12, negative 16, and negative 3. And we're just going to do the synthetic division that we've been doing. They tell us that k equals negative 4. I bring my negative 2 down. Negative 2 times negative 4 gives me a positive 8. 8 and negative 12 is negative 4. Negative 4 times negative 4 is positive 16. Those cancel. 16 minus 16. And then 0 times negative 4 is just 0. We're left with negative 3. So f of k equals f of negative 4, which is going to be negative 3. All right, next question. I'm not going to do number 6. I'm not going to do number 7. I will do number 8. It says use synthetic division to decide whether the given number k is a 0 of the given polynomial function. If it is not, give the value of f of k. Alright, so number 8, we have f of x equals x cubed plus 6x squared plus 9x plus 20, and then k equals negative 5. So basically, we need our remainder to be 0 to decide if negative 5 is a 0 of the function. So we're going to do synthetic division. I've got 1 for r cubed. I've got 6 for x squared, 9x, and then 20. And then they give us that k equals negative 5. So bring our 1 down. 1 times negative 5 is negative 5. 6 minus 5 is 1. Do it again. 9 minus 5 is 4. 4 times negative 5 is negative 20. So, yes. The given k is a 0. Option B. Okay. And then let me do number 9 as well. So kind of similar. Number 9, we've got f of x equals 3x to the 4th plus 7x cubed minus x plus 5. And then they give us that k equals 2/3. All right, I've got 3x to the 4th, 7x cubed, negative 1. Oh, we've got 0 for x squared. So nothing for x squared, negative 1 for x, and then positive 5. And then our k is 2/3. All right, so we're going to multiply the first one by 3. We can cancel that out. We're left with 2. Let me erase this for the next one. Okay, 7 plus 2 is 9. Multiply by 9. 3 cancels out, and we're left with 3 times 2, which is 6. Okay. 4, 6. The 3 still canceling out. Left with 2. So 2 times 2 is 4. 4 minus 1 is 3. Okay, back to where we started. 3, so we've got 2. 5 plus 2 is 7. So this is not a 0, and it equals 7. Our remainder is 7. Okay, so that is the check for understanding 6.1, the questions to look out for the test. For 6.2, we are going to look at we will start with number 1. So this is 6.2, number 1. And we are going to factor f of x into linear factors given that k is a 0 of f of x. Okay? So I've got f of x equals 3x cubed plus 16x squared minus 89x plus 90, and then k equals 2. All right, so we're going to do our synthetic division. I've got positive 16, negative 89, and then 90, and it's given that k equals 2. Okay, bring my 3 down. 3 times 2 is 6. 6 plus 16. I've got 22. 22 times 2 is 44. 44 and negative 89. We've got 45, negative 45. And then negative 45 times 2 gives us a negative 90. Okay, so x minus 2 is a factor. So I'm left with 3x squared plus 22 minus 45. Okay, in order to factor, we are basically doing FOIL backwards. So I need to figure out what all of these pieces are inside of our parentheses. So starting with the x squared, we know that we're going to have 3x and x, because x times x gives us x squared, and then we just have 3, so 3 is only going to go in one of these. And then the very end, we have negative 45. So we need to figure out what two numbers can multiply to get to 45. So we can do 9 and 5. Let's look at those two. And it is going to be negative. So one of these have to be negative. So, and I need to total the x's to 22. So I need to keep that in mind. So one thing that I can do is multiply 3 times 9, because that gets us close to 22. 3x times 9 would give us 27x. And so if I put 5 over here, 5x, this would have to be negative and this would be positive, because minus 5x gives us our 22x. So that is what our answer is. So I've got 3x minus 5, and then I've got x plus 9, and then also don't forget x minus 2. So 3x minus 5, x plus 9, and then x minus 2. Oops, not a period. Okay, great. So there will be a question like this, and also like number 2. So let me look at number 2. And we are going to factor. We have f of x equals 4x cubed plus 23x squared minus 67x plus 40. And then it says factor into linear factors given that negative 8 is a 0 of f of x. Okay, so them telling us that negative 8 is a 0 lets us know that, so if negative 8 is a 0, then x plus 8 is a then x plus 8 is one of our linear factors. Okay, so I'm going to do synthetic division again. I've got the 4 for x cubed, 23 for x squared, negative 67 for x, and then positive 40, and then I'm going to use negative 8 for k. Okay, bring our 4 down. 4 times 8, negative 8 is negative 32. Negative 32 and positive 23 is going to be negative 9. Negative 9 times negative 8 is positive 72. 72 minus 67 is 5, positive 5. 5 times negative 8 gives us negative 40, and we are left with 0 for our remainder. So we have 4x squared minus 9x plus 5. And so we need to factor this all the way down. So let's do like 2x and 2x. And then we need our ending pieces to total to 5. So I could do 4. Let's just play around with it. So if I do, because 2x times, so we're going to have to do 4 to get 5 at the end. So if I do 4x and then x, so 4 times 1, and then we have 5 over here. And then we need them both to be negative because we need a negative 9x. So first we have 4x squared, outside negative 4x, inside minus 5x, and then last would be positive 5. Okay, great. It only takes a couple of seconds to go back and check your work. So we've got 4x minus 5, x minus 1, and then also x plus 8. Okay, I'm just going to go ahead and create all my parentheses and then go in and fill them. So 4x minus 5, x minus 1, x plus 8. All right, great. So there will be a question like that. I'm not going to do number 3. I'm not going to do number 4. I will do number 5. It says to find the polynomial function, list all possible rational zeros, find all rational zeros, and factor. All right, so number 5, I have that f of x equals x cubed minus 8x squared plus 5x plus 14. So since we're looking so in order to find the possible rational zeros, I must find the factors of 14. So, you know, I've got 1 times 14, I've got 2 times 7, and it looks like that is going to be it. So I'm going to select C because it has everything. 1, 2, 7, 14, and it can be positive or minus. Okay, so now we're going to test them. We're going to determine the rational zeros. So using my synthetic division, I've got 1, negative 8, positive 5, and positive 14. And I'm just going to go through the possible zeros. So one way I can start is by a 1. I'm going to start with, I'm just going to start with the positive 1 and play around with it. So bring the 1 down. 1 times 1 is 1. And then negative 8 gives us negative 7. Negative 7 times 1 is negative 7. Add it to the 5 gives us negative 2. And so I can see that our remainder is not going to be 0. So positive 1 is not it. Let me look at negative 1. So 1 times negative 1 is negative 1. This will be negative 9. Negative 9 times negative 1 is positive 9. 9 and 5 gives us 14, and then we have negative. So negative 1 would be a possible answer. So, okay, so that means that x plus 1 is our factor. Okay, so we're left with x squared minus 9x plus 14, and we're going to factor, and I've got x, and I need to get to 14 at the end, so I can do 7 times 2. If I do, I'm going to do both negatives because I need a negative 9x. So we've got x squared, and then I've got minus 2x, and minus 7x gives us the negative 9x, and then negative 7 times negative 2 gives us the positive 14. So I've got x minus 2, x minus 7, and x plus 1. So 1, negative 2, negative 7. But if we were actually like finding the x equals positive 2, x equals positive 7, x equals negative 1. If you are unsure how I did that, we just set them all equal to 0, and you would move your number over, and that's how you can find what x is. The factored form is, so I'm just going to put it in x minus 2, x minus 7, x plus 1. Okay, so there's a question like that. And then also, I'm not going to do 6. I'm not going to do 7. Let me look at 6.3. All right, for 6.3, all right, for 6.3 homework, we are going to be looking at question 4. So this is the one that you will need to look at for your test. There is an example. If you look at the 6.3 notes, there is an example that you can look at down here that is similar to this test question. But it says find a polynomial function of least degree, find a polynomial function f of x of least degree having only real coefficients with zeros of 0, 2i, and 2 plus I. So what we need from these notes is that we need to remember that the conjugate rule states that if there is a 0 of a minus bi, then there also must be a 0 of a plus bi. So if you look at our problem, we have 2 zeros, we have 2i and then 2 plus I, that we are going to need the negative as well. So we are going to have our highest degree at whenever we end, we are going to have 5 as our highest degree. So what that means is we're going to have like an x to the 5th power because we have 5 zeros total. So let's get our notes. So this is 6.3, number 4, and our zeros are 0, 2i, and 2 plus I. So that means that we have that x equals 0, x equals 2i, and then x equals 2 plus I. So that means that the factor would be x minus 0, which is just equal to x, and then x minus 2i, and also x plus 2i, because remember we have that rule that the conjugate is also a 0. It's also a factor. And then same thing for this last one. So these two are both going to have 2 factors. So x minus 2 plus I, and then x minus 2 minus I. So basically we've got x minus 2 minus I, and then x minus 2, and this is a double negative, so it's plus I. So these are what we are going to be basically multiplying. We're going to multiply all of these factors together to figure out what our polynomial function is. So I have x, and then I have x minus 2i multiply x plus 2i, and then I have x minus 2 minus I, x minus 2 plus I. So we need to multiply all these. I will tell you that you should multiply these conjugates together because some of the stuff is going to cancel out and it'll make it easier for you. So let's do this first one. We're going to FOIL. We have our first, which is x times x. So we have x squared. Let me do this so we don't forget our x. We have x squared, and then outside I've got positive 2xi, so plus 2xi, and then the inside minus 2xi. So we already have some stuff that's canceling out. And then our last negative 2i times positive 2i gives us a negative 4i squared. Remember that I squared equals negative 1. So negative 4 times negative 1 is going to be a positive 4 that we are left with. So I'm just going to put 4 right here. All right, and then we need to multiply these over here on the right as well. So let's see if I have enough room. I've got, whenever you multiply with 3 terms, basically what you want to do is like distribute. This x is going to go to all 3 of these terms. The 2 is also going to go to all 3 terms, and then the I is going to go to all 3 terms. So x times x, we have x squared. X times negative 2 is negative 2x, and then x times I, positive xi. Now let's do our 2. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. And then negative 2 times I is negative 2i. And then our last term, negative I times x, negative xi. Negative I times negative 2 is going to be a positive 2i. And then the last term, negative I times I, is going to be a negative I squared. So again, we have stuff that we are canceling out. I have xi and negative xi that are going to cancel. I've got negative 2i with positive 2i. And then our I squared is a negative 1, so it's a double negative. So we end up with the positive 1, so plus 1. So let me rewrite this. I have x, and then I have x squared. These have canceled out, and I'm left with a positive 4, so x squared plus 4. Okay. And then I have x squared, and then negative 2x. Negative 2x, I've got minus 4x. We can join our like terms. And then we have 4 and then plus 1, so plus 5. Okay, I'm not done. I still need to continue multiplying these out. So I'm going to multiply these two. So our distributing again, x squared would multiply each of these 3 terms, and then our 4 would go through and multiply those 3 terms. So remember our x squared and x squared gives us x to the 4th. We add those two. X squared times negative 4x would be negative 4x cubed, because this is squared and then this is just 1, so we get 3 cubed. And then x squared times 5 is going to be plus 5x squared. Now we can multiply our 4. 4 times x squared is positive 4x squared. 4 times negative 4x is negative 16x. And then 4 times 5 is positive 20. Alright, so we've multiplied those. Now we just need to multiply our x to everything. So we get x to the 5th minus 4x to the 4th. Oh, we need to join these two together. That's going to be 9x squared. Multiplied by x gives us 9x cubed. And then x times negative 16 is negative 16x squared. And then plus 20x. All right, so this is what our answer is going to be. We've got x to the 5th minus 4x to the 4th plus 9x cubed minus 16x squared plus 20x. Woohoo! So yeah, just when you're multiplying, start with the conjugates because stuff is going to be canceled out and you will get rid of those imaginary numbers.